The most basic functionality of the MDC controller is to monitor an array of fans that are being controlled by an external 0 to 10 volt control system. The signal may be coming from an application controller, a potentiometer, or a building management system. In this system, the fans are configured to respond to the external 0 to 10 volt control signal via the analog input terminals on the fan, and the MDC controller is configured to read only from the fan holding and input registers over the RS485 Modbus RTU network. When in monitor-only mode, the MDC controller offers the flexibility to be powered from a separate DC power supply or to use the voltage output from one or more fans in the array. If an external power supply is to be used, the two power terminals on the left can accept a voltage between 10 and 48 volt DC. The next block of terminals to be used are the fan network connections. RSA and RSB are for data transmission and reception. The ground should be connected to all devices in the network, and the plus 10 volt DC input for when the MDC is being powered from the fans in the array. If the MDC is being powered using an external DC voltage supply, the plus 10 volt DC connection to the power output terminals from the fans in the array should not be used. The controller should either be powered using an external power supply or powered from the DC fan output terminals, but not both at the same time, as this may cause damage to the controller and the fan control circuit. After the fan array network has been initialized, the controller defaults to monitor-only mode and displays the status of the first fan in the array. Using the up and down arrows, the user can view operational status, including whether there are any alarms or warnings, current power consumption, current speed, motor temperature, which in the case of an M3G 084 this is inactive, electronics temperature, operational hours, current fan control signal, and fan serial number. The user can view the status of each fan in the array using the left and right arrows, and can view an overall status display which lists the total power consumption of the fan array. In monitor-only mode, it is possible to measure the volume flow passing through the fan array or the pressure difference between the suction and exhaust side plenums. This requires the use of a pressure transducer whose analog DC output signal is connected to the MDC controller. To measure the volume flow passing through the fan array or the pressure difference between the suction and exhaust side plenums, the MDC needs to be connected to a power supply with an output of at least 24 volt DC to power the pressure sensor. The sensor should be connected to the control input terminals and the fan communications connected to the fan array network terminals. This is the smaller of the two units that we're using to demonstrate the functionality of the MDC controller. Installed on the suction side is a variable position louver which we're using to simulate a filter becoming progressively blocked. In the suction side plenum, we're using a pressure transducer of the diaphragm type to measure the pressure difference between the plenum and the pressure tappings on the inlet rings. The fans are the K3G 250 type. They've been fitted with flow grids and finger guards. The pressure tappings have been joined together to create an averaging pressure circuit, and we have some remote control switches that can switch off any of the two fans to simulate a fan failure. To illustrate the capability of measuring the volume flow passing through the fan array in monitor-only mode, we are using a potentiometer to regulate the speed of the fans and a pressure transducer whose output is connected to the MDC controller. In this example, we are using the two-fan demonstration unit that has a circuit joining both inlet ring pressure tappings together to produce an average pressure measurement and a single point measuring the static pressure in the suction side plenum.
Using the main menu, which can be found by using the left arrow on the MDC keypad and choosing the operation mode monitor, we can enable the sensor. For volume flow measurement, the pressure range of the installed pressure transducer must be specified along with the K factor of the fan inlet ring. In this case, we're using a 0 to 2000 pascals pressure transducer and the K factor of the inlet ring is 76. After a reset, if we return to the overall display screen, in monitor mode, this has added the volume flow to the status screen.
The addition of a pressure transducer also provides the capability to measure system pressure. This can be either the negative pressure that would be present in the upstream suction side of the array, the positive pressure in the downstream exhaust side of the array, or the differential produced across the upstream and downstream sides of the fan array.
As with the selection of volume flow measurement, using the main menu and choosing the operation mode monitor, we can enable the pressure differential measurement. For pressure measurement, only the pressure range of the installed pressure transducer needs to be specified. In this case, it's a 0 to 2000 pascals pressure range. Returning to the overall display screen in monitor mode adds the differential pressure measurement to the overall status screen.